All right, we are ready to start Concept 2 notes, and in this section we are going to be talking about chemistry of life. When we're talking about this, really all of our sciences, whether it's chemistry, biology, or physics, they're all related to each other. I like to say, to make Miss Man mad, that biology is the only reason we care about chemistry. All living things have a similar organization in their life. So if we start at the very bottom, we will have things that are made up of matter. And matter is anything that has mass and occupies space. So if mass and matter are the smallest levels of organization, if we look at our chart here, that means it must be composed of atoms. And atoms are the smallest part of an element that still have properties of that element. So think of the periodic table. We want to have, if we're talking about hydrogen, an atom still has properties of hydrogen. If we go any smaller, then we won't know that we're talking about hydrogen anymore. When thinking of the periodic table, there are 6 specific elements that are necessary for all living things, and those are C for carbon, H for hydrogen, O for oxygen, N for nitrogen, P for phosphorus, and S for sulfur. And then as we move up in our classifications, we had our atoms making molecules here. And so now we're ready for cells. And cells are the most basic unit of life, meaning that if they're not made of cells, they're not classified as living things. And this brings us to the molecule of water. We are going to spend a good amount of time talking about water because of how important it is to all of life's processes. So hopefully, as you know, water is H2O, and it's a molecule that's made up of 2 atoms of hydrogen that is covalently bonded to 1 atom of oxygen. As we said, water is important to all living things, so we are saying that it is critical for all of life's processes. We have to have water. After all, you're made up of almost 70% of it. And then because of that, water also has many special properties, mostly due to the fact that water is a polar molecule. And we will talk in a minute about what polar or polarity means. And as we said, water is a polar molecule, but molecules also have the option of being non-polar. So let's talk about what these are. And when you hear the word polar, I want you to think of actual North Pole and South Pole, and that'll probably help you on this idea. So polar molecules are ones that have unequal distribution of charges. So literally, one side is more positive and one side is more negative. Because of this means they will dissolve in water. So an example is water itself. Now if we move on to non-polar molecules, there's no poles. There's no North Pole, there's no South Pole, which means that there is no separation of charges. So no positive or negative poles are being formed, which means that water does not dissolve in water. And examples of this are things like carbon dioxide, oxygen, and lipids. Lipids are things like oil, and you've probably already learned that oil and water don't mix.